So what I was going to go through was build on some of the things we've heard this morning and this afternoon, but look specifically on how we build security into the IoT solutions that operators are delivering today, and also the emerging networks that they're starting to build to cope with the growth of IoT traffic. Have a quick look at some of the threats. I mean, we've talked about some of the existing threats, some of the emerging threats, but also it's not just one type of security threat. There are multiple threats that we need to start considering, and new threats coming along with IoT. And then also think about the different models that the operators can be using to deliver IoT services. And again, some of this, we talked this morning about the different commercial models and how we support the different verticals. And what we see at F5 is different architectures being deployed, or different models of how the different parts of the network are working together. We often talk about sort of IoT. I mean, that's the phrase we all use, and prior to that, sort of M2M. I suppose the one phrase that, when I think about IoT, really we're talking about from device to application. It's not necessarily just a device talking to another device or machines talking to machines. What we're seeing predominantly is the device, whatever that device is, talking across some sort of network to an application, and predominantly it is that sort of application rather than peer-to-peer type traffic. And when we think about security, it occurs in all those places. We have to have both security of the device. The device needs to be secure, be invulnerable, but also we need to be thinking more on how we protect the network and the application as well, the firewalls and the protection we put in there. And at each layer in the network, we have different security controls, and they combine. So there's no one point where we say, this is where we're applying the security. It's basically combining all the different parts of the network. To explain that again, I mentioned that we're looking more at the application, and all our devices are talking to the applications. An example of this, F5 as a company, traditionally we've been sitting in front of applications within the data center, and what we see now with IoT traffic is actually those applications are changing. We're going away from the traditional web applications using HTTP traffic and looking at more IoT specific protocols. So MQTT is a protocol that we're seeing significant interest in now as a way of providing connectivity from the connected devices into the data center, into the applications. And MQTT, it's again a very sort of lightweight protocol, specifically for things like remote sensors, but also more complicated workloads like connected cars and industrial connections. MQTT, it's quite interesting as well. For instance, it's also the protocol that underpins Facebook Messenger. If you have Facebook Messenger running on your laptop, then actually you're using an IoT protocol because it's well suited to that sort of connection and subscribe model. Now, the way MQTT works is actually, even if you take the example here where we have a temperature sensor and you could be looking at that temperature sensor on your mobile device, it's not a direct device to your laptop connection. We're still going through the application. We're using the application as a broker. So effectively, we have all our different sensors. They will publish the information to that MQTT broker, and then all the different devices that want to connect to that, be they laptops, mobile devices, other IoT devices, will actually subscribe to the MQTT broker and have the information pushed out to it. So again, even when you see this connection where you have a sensor here and it's talking to your mobile phone in a few feet away, you're still going through the data center, through the application, through the network, and using protocols like MQTT. And we need to look at how we provide the security for these protocols, and also what new threats, the fact that we're no longer just using HTTP, TCP, etc., but using new protocols, and how we mitigate those within the data center. The other thing that, when we're thinking about IoT specifically, IoT is the Internet of Things, and clearly it is many different things. I probably should use a capital T for the things, because and I've taken two extreme examples just to show the range, from something like a remote monitoring sensor to autonomous vehicles, I guess, are the two, very stereotypical examples. And when people talk about these, we often talk about the difference, it's like, well, a sensor, that's very much, it's a low bandwidth, and we talked about the different RAN technologies to support sort of narrowband IoT and low bandwidth connections. And, an autonomous vehicle, it's higher bandwidth, we might have more instantaneous workloads. However, from a security perspective, it's not necessarily the bandwidth which is the most fundamental difference between the different applications, between the different things that we're looking at. For sure, bandwidth's important, and how you dimension the network will depend on the bandwidth. And if you have lots and lots of low bandwidth connections, that might place different requirements on your firewalls and your network and the infrastructure. But actually, when you think about your overall security architecture, there's lots of other things to consider. So I mentioned a moment ago the different protocols, and having that sort of protocol awareness and being able to inspect those protocols, and not just looking at the IP layer and the TCP layer, which firewalls traditionally do, but being able to look at different IoT-specific protocols. If we take our remote monitoring, again, this remote monitoring device, again, we mentioned earlier, it's typically got a limited battery life. It's not going to have many frequent updates. It might have quite a small CPU performance, so it might not be able to run malware scanners or even things like TLS certificates or encryption, or all the things that we would have typically running on laptops, on smartphones and things to provide security in the endpoint. So we might need to provide additional security or additional controls for our remote monitoring apps because they can't necessarily perform that inherently. Likewise, when we go to autonomous vehicles, again, the things we want to provide for security might be different, both in terms of the networking performance. So we're looking at building a lower latency network because we need to have quicker connections between the device and the application. And also, it goes without saying, things like cars and drones and those remote management items are safety critical. So we often have to have better safety systems in there, whereas maybe if it's a remote monitor, it doesn't matter so much. So again, as I said, IoT is different things, and we need to think that actually, as we're talking about, there's many different verticals, and each one will have its own security requirements. That said, when we're building networks, we always think about, you have the verticals on top of that network, but actually, to make networks cost effective, we've always looked at how you can converge the infrastructure. And that still stays the same for IoT. We still have a convergent layer using IP transport, using the internet for connectivity, wanting to provide, connectivity for all these different things over the same radio networks, over the same network infrastructure. So what this means is we need to build our IoT infrastructure to provide the flexibility to support all these different devices and the different security postures of those devices. Looking at some of the threats then that we need to build into our security infrastructure, I suppose when people think of security, the first thing we always read when we see it on the first page of the register and different web articles, it's things like sort of volumetric attacks. Volumetric DDoS attacks always get the press because they're tens of gigabits, hundreds of gigabits, thousands of gigabits now, and these are the big high-profile attacks. Probably more interestingly, and harder to defend are the application layer DDoS attacks. A volumetric DDoS attack, it gets a lot of press, but it's quite easy to see hundreds of gigabits of traffic. When you start looking at application layer attacks, which are now starting to exploit vulnerabilities in MQTT, in vulnerabilities in CoAP and other protocols, having that protocol awareness is also something that we need to have in the different parts of the network. And then thinking about attacks going out to the devices themselves, so things like sort of paging storms and signaling attacks. I mentioned that a remote monitor might have a battery in it that might be going to last 10 years. Well, something that might be a fairly benign attack of just sort of getting paging message to that might run down that battery in a few weeks, which might be a very significant attack on those sort of devices. It might be less important for an industrial digger or something that's powered by the mains. But again, it's looking at different attack vectors against different devices and having the flexibility to provide against those direct attacks. The direct attacks are the things I think that, when we think about security, we're all thinking about, the hacker coming into our application, into our device and launching an attack, be it a DDoS attack or some sort of extraction of data. I think within the realm of IoT security, and particularly for the network operators, abuse of the service is perhaps more interesting. Particularly when we talk about new commercial models. As we've said, IoT is going to be, we're going to have billions and tens of billions of devices, eventually. And certainly where you're having these devices, it's going to be, the commercial models around them are going to be you're paying for the service. You're going to be paying a few pounds, a few euros per month for that service. If you can take the SIM out of your sort of bag tracker that's only using a few kilobytes a day, and actually put it into your smartphone, and then have free internet access for a few dollars a month, then it's quite an easy service to abuse. So there are ways to tie that down to make sure you restrict the service. But what you need to do is not have. You need to make your firewalls flexible enough that they're not restricting the service overly and stifling innovation. So if you look today about how you manage quotas, etc., they might not allow you to develop the more innovative services in the future. So I think actually having networking devices that are preventing abuse of the service is one of the key things, particularly for network operators, that they need to make sure that their service, they can offer the service at a very cost-effective point, but not have it abused. And the other thing, IoT, we've heard about IoT being used as for launching bot attacks, and they really are an ideal vector for this. We've started hearing being called as sort of thing bots, effectively a herd of IoT devices. We've seen there's been some high-profile attacks. If you go back a couple of years, there was the Mirai attack where CCTV and routers were compromised and used to launch an attack. And those attacks are still going on within F5. We publish through our F5 labs. We publish reports on what we see, the attacks we see on the internet, and the sort of thing bot attacks. Actually, although Mirai was maybe the last really high-profile one, in the last year we saw a 250% rise in the amount of thing bot attacks. So that traffic is really going up. IoT devices represent really a really good vector. Because as we mentioned earlier, the usernames and passwords are often default settings. They're quite easy to compromise. It is the bot of choice for the discerning bot herder today. So it's how we put security controls in the network to prevent that. For sure, we can protect, on the device level, and there are initiatives, and F5's participating in some of those initiatives to actually define standards for those end devices, things like the named device networking standards, which specify how you can provide control for these devices. But still, being able to have network controls and application controls is key to make sure that compromised devices aren't acting as a launchpad. Thinking then of the different architectures for IoT services, I suppose the most common one, what we see today, is that sort of over-the-top service where, again, I'm taking here sort of mobile examples where we have devices connected to a mobile network, but really just using that mobile network for connectivity, and then connecting to an over-the-top application provider, which is living in the public cloud or the private cloud. And from a mobile perspective, this is fairly straightforward. We can just have sort of our standard SIMs that are deployed in the devices, allowing connectivity into that application. Because we're transiting the traffic over the internet, that obviously gives a very wide threat surface for the attacker to come into the internet and both attack the application and the network. So traditionally we see application firewalls being deployed. And this is, we use the term firewall generically. Wherever we have a security threat, we put a firewall in. But really we need to be quite specific about the types of firewall we're using now. Application firewalling, we're looking very much on the layer 7 of the network, looking at the applications, trying to identify specific threats. For application traffic, I mentioned MQTT traffic. So having MQTT awareness in your application firewall and being able to detect things like an attacker doing multiple subscribe requests and trying to subscribe to different channels and maybe either DDoS the service or extract data or connect to channels is something that we can use our application firewall to protect against. And again, this is something, when we look at this model of going from device to application, it's exactly the same as, we've previously seen in the internet, where we have, web application firewalls. We now have IoT application firewalls and providing that layer 7 protection. But of course, because we have the internet there, we also need to think about, protecting the network itself. And here we're having network firewalls to protect against the access network. Again, within the mobile network, we've seen network firewalls, so protecting on the GI interface, if you like, on mobile networks. And for IoT traffic, we see this, again, becoming more than just a very simple networking device to become a much more sophisticated device-aware and service-aware firewall. So for initially, that could be used for preventing DDoS attacks and the sort of paging attacks and things we were talking about. And also if we have infected devices, protecting our thing bots from flooding the network, both from detecting the attacks, but also stopping malware on devices being able to connect to the command and control servers. So while you might still have the malware on your device, if it can't actually be turned on, if it can't actually be instructed to launch an attack, it's effectively, sort of immune from causing problems. So some of the things that the networking firewall can do now is more than just providing the sort of stateful network firewalling, but it's providing this anti-DDoS and DDoS mitigation features for the network. The other thing that we need to consider from our networking firewalls and things that change when you look at IoT services is the type of traffic. I mentioned that we have a lot maybe of lower, a lot more connections of lower bandwidth, the typical sensors and those sort of things, which often means that we have lots and lots of connections through the firewalls. And traditionally networking firewalls, while they've been good at handling a large amount of bandwidth, if you have lots and lots of low bandwidth but long-lived connections, which you typically see in IoT networks, that changes some of the requirements on the networking firewalls. So with IoT, we are seeing changes to the requirements and some of the specifications we see on those devices. The other thing we should also be thinking about is how we limit that abuse that we talked about. How can we make sure that we're using our network, if we're offering an IoT service or charging for an IoT service, how we make sure it's actually being used for IoT traffic. If it's over-the-top traffic, that can be quite challenging, because we don't necessarily see that. Again, the traffic typically is end-to-end encrypted. We've got TLS tunnels. We can't necessarily look inside it. So again, we can see things like using heuristic analysis to actually look at the traffic and identify whether it looks like MQTT traffic or whether it looks like Facebook traffic or YouTube, and blocking either those applications or whitelisting specific traffic to make sure that where we're charging for an IoT service, we are only being used for an IoT service. As I mentioned, the end-to-end encryption makes that more challenging, but there are still ways, particularly integrating DNS. IoT devices are still making DNS lookups, and we can use DNS, which generally is still unencrypted, to actually make sure that connections from our devices are going to IoT devices and not just being used or abused for other purposes. The other thing we've started to see at F5 is the actual network operators doing more integration of their services with the IoT services themselves. So rather than just using over-the-top services, offering maybe more walled garden services, or I suppose like a positive security model. So actually, rather than saying this device can connect to anywhere and will block some of the bad sites, we're actually now going to say, if you buy a remote monitor, it's only going to be connected to these sites. And maybe it will be the end user who'll say, I'm always going to connect to my web, my IoT application living in the cloud or living in the public cloud or living in my data center. Or it could be certain services that when you pay for that charging plan, that will be what you're allowed to connect to. And so you have this kind of walled garden positive security model. And again, this can be looking at the traffic. It can be looking at sort of DNS. It can be doing heuristic analysis. If the operator looks at both the networking firewall and the application, they can actually decrypt the traffic and they can do DPI and things like that on it to make sure that you are using the traffic for its intended purpose. And again, preventing abuse where the attacker now, if it's walled garden, they might not be able to get into the internet over it. But preventing the attacker just buying a SIM or taking a SIM from his employer or the service he's providing and using it in different devices or unregistered devices. So historically, sort of walled garden, when operators first deployed the internet, the mobile operators came up with this sort of walled garden model, which largely is gone now because everybody wants to use the whole internet on their phone. However, when you look at devices, it's no longer about connecting to the whole internet. It might be having that connectivity there, but you want your remote monitoring app to connect to your remote monitoring service. You want your CCTV to connect to your video service. So a walled garden model is much more applicable in those kind of architectures. And again, we can use our networking firewall to enforce those rules. I suppose the combination of those two previous cases as well is more of a collaborative model where the network operator is still providing the connectivity, but maybe working in partnership or working with specific customers to have an insight into the application traffic. So rather than a pure over-the-top model, they might want to have some relationship with the actual IoT application. And this can lead to again, some interesting use cases. Things like providing identity. If it's not the mobile operator, you might not want to provide, say, the full MSISDN number or the full subscriber details, but you might want to insert into the traffic some identifiers. So, for instance, you can say that this traffic is from certain locations, it's a certain user, it's an authorized user. Again, because on the mobile network, the user or the device is going to be authenticated by the SIM, we can actually use that SIM authentication information and insert it or insert an anonymized version of it into the traffic to provide to the application and the IoT application. And that gets around some of the challenges as well about how do you actually put a username and password into your IoT device? How do you stop people just using default usernames and passwords in the IoT devices? So things like within a collaborative model, again, we can use everything we talked about previously. So things like the positive security models, the walled gardens, inspecting the traffic, preventing abuse, but also look at things like providing location information and identity information. And this is somewhere where even when you have an over-the-top vendors, the actual network operator can be adding additional value because they have unique information that they can provide, and they can provide in a secure way to the application vendor, if they're not the same people. And also things, we talked about the end-to-end encryption. But if your end device is in the field for 10 years, you can guarantee that the security and the version of TLS it's using is going to be out of date, after a while. So we can do things on our network firewall, things like the TLS upgrade. So you might have between the device and your networking firewall TLS 1.1, but from your networking firewall across the internet, you could actually re-encrypt that as TLS 1.3. So you can use your network firewall to enhance the security. The other thing that we see coming a lot, being talked a lot, particularly in terms of IoT, is 5G and the evolution of 5G and network slicing. This is potentially very interesting because it changes both the way we can apply security. We can have different networking slices to provide our security, so we can segregate and provide different qualities of service from our devices right through to our application, but also do things like break out in different places. So you can have lower latency because you can break out to different EPCs, different gateways earlier on in the network, whereas things like your smart meters and your sensors that aren't necessarily latency sensitive can go back to central data centers, one per continent or one per region, etc. Obviously, a lot of the network slicing and the concepts behind network slicing, the end-to-end network slicing through the RAN, right through the network, is coming with 5G. But what we already see is operators starting to look at implementing some of the ideas around network slicing in a sub-network way. So performing slicing and steering within the GI LAN, if you like. So once the traffic has gone through the EPC, and connecting to different applications, and then also steering to different EPCs, so we can have different core networks and use existing functionalities, things like DNS records, but control those DNS records in a dynamic, intelligent, and device-aware way. So looking at the traffic and steer the users and steer the devices accordingly. And just, I suppose, in summary, I mentioned sort of F5, and traditionally we're known very much within the data center. On the left-hand side of this diagram, the right-hand side of this diagram, where we sit in front of the web applications and the IoT applications. But increasingly, as I mentioned, we are now being deployed as this sort of intelligent, very flexible network firewall, both within the mobile networks and also providing sort of out-of-path mitigations and security mitigations for fixed networks, and the consumer IoT coming across the fixed networks. And then in future as well, looking at the steering within the RAN and towards the different EPCs within the mobile network. So again, it's this flexibility, this layers 4 to 7 flexibility that we see in multiple parts in the network, which is being driven very much by the need to provide flexibility for IoT. So I think just in conclusion, just to sum up, the controls we need to put in, we're putting in multiple locations. It's not just looking at securing the device or the application, but it's securing multiple parts of the network. And while I talk about a device being a firewall, it really is having a lot of functionality, a lot of device awareness to provide the flexibility to support the different IoT service delivery models.